Good day, everyone. Today we will talk about the Testnet Alpha Roadmap study notes. So, this is the road to Testnet Alpha release. So, we have seen the green with check. So, these are the milestones that have been achieved, and these are the things to do. Okay, so we will talk about each milestone one by one. So, let's start with the extralogical API, followed by the string ID service, persistent mempool, transaction validation and internal state, block schema and storage with Merkle root, block production phase, and persistent chain state. Then we will have a short two-question quiz to um, solidify our understanding. Then we will proceed to the following milestones to be achieved, and those are the peer-to-peer networking foundation, gossip protocol for transactions and blocks, fork choice mechanism, resolve competing chains, developer CLI and testnet packaging, and lastly, the testnet alpha release. So let's start with extralogical API. So what is extralogical API? Extralogical API, or the Application Program Interface, is an interface that allows Tau's core logic engine to interact with the outside world and handle functionalities that cannot yet be expressed directly in the Tau language. It acts as a bridge between Tau's internal formal logic and external systems. Imagine TauNet as a new computer system with its own unique brain and language. The extralogical API is like a universal translator or a set of ready-made tools that allows this system to talk to and to use other existing programs or computer programs or services. It handles essential tasks such as cryptography for security, networking for future communication, and transaction timing. This is crucial because it lets Taunet connect to existing Web3 services like decentralized storage, example IPFS, or DeFi services without having to build everything from scratch. Senior Dev Andrei Korotkov designed the architecture for these APIs, connecting them to external libraries for cryptography and peer to peer communication. Initially, communication occurs via standard input and output, with future plans for more advanced messaging. The second milestone that has been achieved is the string ID service. This service is designed to reduce complex strings, long pieces of text or code, into short, unique identifiers. Think of this as a system that assigns a very short, unique serial number or nickname to every long document, piece of code, or complex text. This makes it much more efficient for testnet to reference, process, and store information quickly and with less memory. It's an internal optimization for data handling. Okay, let's continue to the third milestone that has been achieved. This is the persistent mempool. A mempool is a waiting area for all validated transactions that have been submitted by users but have not yet been included in a block on the blockchain. Persistent means these transactions are reliably saved even if the system reboots or crashes. This is like a secure waiting room for all the pending actions, transactions, new rule proposals, etc., that users have sent to Taunet. The persistent part means that nothing gets lost from the waiting room, even if the computer running Taunet unexpectedly turns off and on again. It ensures that every legitimate transaction submitted will eventually be processed and added to the blockchain, guaranteeing the network's continuous and reliable operation. The fourth milestone that has been achieved is the transaction validation and internal state. This involves checking each income transaction to ensure it is properly signed, correctly formatted, and unique. Once validated, these entries are added to the mempool and applied to the system's internal state. This milestone means that the Taunet can verify every single action, transaction submitted by users to ensure it's legitimate and correctly formed. It checks if the transaction is authentic, follows the right format, and hasn't been duplicated. Once a transaction passes these checks, Taunet updates its internal records to reflect that change. Senior Dev Andrei Korotkov has fully implemented the logic for creating, linking, and storing blocks, including pulling transactions from the mempool, signifying that the fundamental mechanisms for validating transactions and integrating them into the blockchain's current state are largely functional. This is critical for maintaining an accurate and consistent record of everything happening on the network. The fifth milestone that has been achieved is the block schema and storage with Merkle root. This defines the structured blueprint schema for how data is organized within each block of the blockchain and how these blocks are stored. A Merkle root is a cryptographic hash that summarizes all transactions within a block, enabling efficient verification. This is about establishing the standard blueprint for how each page, block, of the blockchain's record book is designed and saved. The Merkle root is like a super efficient digital checksum or fingerprint for all the transactions on that page. This is vital for security. It allows anyone to quickly and easily verify that a specific transaction is truly included in a block without having to re examine every single transaction in that block. Andrei Korotkov work in July 2025 included assembling blocks from the mempool transactions, linking them, and ensuring correct Merkle roots, thereby creating a persistent historical ledger. Transactions on Taunet can include both coin transfers and proposals for new rules. As you can see here, we have coin transfers and new requirements, which are transactions. The sixth milestone that has been achieved is the block production phase. This phase introduces the process of creating and adding blocks to the blockchain within a local instance of Taunet, meaning on a single computer without network involvement. Transactions, including rules and transfers, are securely bundled into blocks and cryptographically linked to form a persistent and ordered chain. This means the fundamental process of generating and adding new pages, blocks, to the blockchain's record book is working correctly, but only on an individual computer. It proves that that the core mechanism for securing bundling transactions, both coin transfers and new rules, into blocks and linking them in a continuous, ordered history are functional. This is a crucial step to ensure the chain building logic is solid before integrating network communication. Senior Dev Andrei Korotkov successfully completed this milestone, including assembling blocks from the Mempool, linking block hashes, and storing new blocks in the database. The seventh milestone that has been achieved is the persistent chain state. This milestone ensures that the entire historical record and current state of the blockchain are reliably stored and can be reconstructed from the ground up, from the Genesis block to the most recent one, including all rules and transactions. This is a cornerstone of the blockchain's reliability. It guarantees that the entire history and current status of TauNet are permanently saved and can be perfectly rebuilt at any time. If a node, a computer running TauNet, goes offline, it can restart and accurately reconstruct its complete history, from its very first block to the most recent, including all transactions and new rules that were applied. Senior Dev Andre achieved this by changing the system to reconstruct the state directly from the sequence of historical blocks and transactions, moving away from a snapshot based approach. This involved significant collaboration with the development team to overcome challenges, including those related to the pointwise revision mechanism, which allows for updating parts of the Constitution or rules without rewriting everything. This ensures a robust and verifiable foundation for the blockchain. This is one slide of my previous lesson about pointwise revision. Please check it out to see more of it. Thanks. So we have already 7 milestones that have been achieved. So there are only remaining 5 more remaining. Okay, so before I continue with these topics, let's have a short quiz first, just to two core questions to deepen our understanding. Please feel free to pause the video to think for your answer. Question 1. Which recently completed technical milestone for the Tau Net Testnet Alpha development temporarily handles functionalities such as cryptography, networking, and transaction timing, and acts as an interface between the real world and Tau's logic engine? A. Full implementation of the Controlled Natural Language (CNL) interface for all users. B. Integration of external machine learning models for predictive analytics. C. Successful completion of the extra logical API. Or D. Public release of the testnet alpha to all community members. So the correct answer is letter C, successful completion of the extra logical API. The extra logical API has been officially completed as a step towards that testnet alpha. Its purpose is to handle cryptography, networking, and transaction timing, as well as functionality that cannot be expressed in the Tau language. It also serves as an interface between the real world and Tau's logic engine, allowing users to operate the system even as the language continues to evolve. Senior Dev Andrei Korotkov confirmed this work on the architecture and specification for the extra logical APIs, including crypto libraries and peer to peer communication layers. Question 2. What significant technical milestone for the Tau Net Testnet Alpha development completed by senior developer allows the blockchain to reconstruct its history from the Genesis block? A. The full integration of proof of execution for all transactions. B. The successful implementation of the persistent chain state. C. The public release of the testnet alpha client for widespread use. Or D. The development of a comprehensive graphical user interface for non technical users. So the correct answer is letter B, the successful implementation of the persistent chain state. Senior Dev Andrei Korotkov explicitly stated, "Last month, I successfully completed the next milestone on our roadmap, and that is the persistent chain state." He explained that this allows the blockchain to reconstruct its current state from historical blocks from the ground up, from the Genesis block up to the most recent block. Andre also noted that a reliable chain state in place and ready for action is one of the foundational pillars for the testnet alpha. So now let's talk about the the things to do. So let's go to 8 things to achieve. So this is the peer-to-peer networking foundation. So what is peer-to-peer networking foundation? In a traditional online system, your computer connects to a central server to get information like a website. Peer-to-peer networking means that your computer, a node in this context, can directly connect and communicate with other computers, other peers or nodes on the network without needing a central go-between. Imagine a group of friends who wants to share notes for a class. Instead of everyone sending their notes to a teacher who then shares them with everyone else on central server, P2P networking is like each student directly sharing notes with every other student. This is the fundamental layer for any decentralized system, as it allows all the individual Taunet instances to find each other and talk. Senior Dev Andrei Korotkov has been active in integrating external libraries like OpenSSL for cryptography and libp2p for peer-to-peer communication to build the architecture for Tau Net nodes. Initially, communication is simpler, standard input-output, but the goal is to use more advanced messaging like message broker in the future. This is a major step towards having the first running node of TauNet. Gossip Protocol for transactions and blocks. What is Gossip Protocol? A Gossip Protocol is a way for information to spread across a network efficiently. Instead of one computer sending information to every other computer directly, each computer just tells a few of its neighbors, and those neighbors then tell a few of their neighbors, and so on. This makes information spread quickly throughout the entire network. This is like a rumor spreading through a village. Someone hears a piece of news, a new transaction, or a completed block of a transactions, and they gossip it to a few friends. Those friends then gossiped it to their friends, and soon enough, everyone in the village knows the news. In Taunet, this protocol ensures that all new user actions, transactions, and newly created batches of validated actions, blocks, are rapidly and reliably shared with every node on the network, keeping everyone updated and synchronized. Fork choice mechanism. Resolve competing chains. In decentralized networks like blockchains, it is possible for different parts of the network to temporarily create different versions of the history, called forks or competing chains. If, for example, two different nodes propose a new block at almost the same time, a fork choice mechanism is a set of rules that all nodes follow to agree on which version of the history, which chain, is the correct one to continue building upon. Imagine if two different scribes independently write down the next page of a history book at the exact same moment. Both pages are valid, but they lead to slightly different versions of the book. A fork choice mechanism is like the rule that says, okay, if this happens, we all agree to follow the book written by scribe A, or the longest book, or the book that has the most work put into it. For Taunet, a mechanism will be defined to resolve these competing chains when multiple views of the chain are suggested. This is crucial for maintaining a single, consistent, and agreed upon history of all the rules and transactions of the network, ensuring the blockchain remains cohesive and trustworthy. Tau aims for a system where the traditional forks due to protocol changes are avoided because the rules themselves can change through consensus. Tau is designed to flexibly evolve and update its own fundamental rules without needing to split into separate, incompatible versions of the network. For example, traditional blockchain forks. Imagine a group of people playing a game with a fixed rulebook. If a significant number of players want to change a core rule but others don't, the game might split into two. One group plays by the old rules and another by the new ones. This is similar to a fork in traditional blockchains like Bitcoin or Ethereum, where disagreements over protocol changes can lead to two distinct competing blockchains. This creates confusion, divides the community, and can impact the value of the cryptocurrency. Tao's self-amending nature. Tao is different because its rules are not set in stones. They are meant to be continuously defined and redefined by its users. Think of Tao as a living, editable rulebook that all participants share. Instead of a core development team making decisions, and pushing updates that might cause division. Tao's users themselves collectively decide how the network should operate and what its rules should be. They express their opinions, ideas, and requirements in the Tao language, a formal logical language. Laws of changing the laws. A core innovation of Tao is its ability to reason about its own rules and define how those rules can be changed. This is referred to as the laws of changing the laws. This means that the community can agree on a framework for evolving the system rather than having to restart or split when a change is desired. Pointwise revision is when users agree on a change. Tao employs a mechanism called pointwise revision. This allows the system to update only the specific, logically relevant parts of its code or rules without needing to rewrite or replace the entire system. This ensures that the system evolves smoothly and consistently. Consensus driven updates. The ultimate outcome of these discussions and proposals is a consensus among users about the network's next version. This collective agreement then automatically becomes the new software update for Tau, effectively eliminating the need for a fork because the entire network evolves as one unit based on its users' shared decisions. The next thing to do again after that is the developer CLI and testnet packaging. So a CLI is a command line interface. It is a text-based tool that developers use to interact with a computer program or system by typing commands. Testnet packaging refers to the process of bundling all the necessary software components into an easy to install package like a .exe for Windows or a .deb for Linux. The developer CLI is like giving engineers a direct keyboard to type commands and tell Taunet what to do, like submitting new rules or checking its behavior. Testnet packaging is like putting all the pieces of a complex Lego set into one box with clear instructions. This makes it incredibly easy for anyone, especially developers and early adopters, to download, install, and start running their own TownNet node and begin interacting with the network without a complex setup process. This ease of access is vital for attracting participants to the testnet. And this is the testnet release. This is the first public release of the TauNet blockchain. It's an alpha version, meaning it's an early, foundational release, a minimum viable product designed to demonstrate core functionality and gather feedback. It's explicitly described as a collaborative dev platform. This is the grand opening for a very early version of the test Taunet. It means the system is live and accessible to users for the first time. The key innovation here is decentralized user control. Users won't just be passive participants, they will be able to directly influence and change the core rules and features of the blockchain itself by submitting new rules adapting a local blockchain. This is achieved through Tau's unique pointwise revision mechanism, which allows parts of the system's constitution or rules to be updated without needing to rewrite the whole thing. This alpha release is crucial for demonstrating the potential of TauNet to be a blockchain that becomes everything its users collectively want it to be. While minimal initially, it lays the groundwork for user driven evolution and adaptation. So, we have one, two, three, four, five, six. We have seven milestones that already has been achieved, and there are remaining one, two, three, four. We have five remaining more milestones. Stones. So let's have a two core questions to deepen our understanding. Again, please feel free to pause the video. Question 3. Which upcoming technical milestone for the Tau Net Testnet Alpha development is described as the next major step for senior developer Andrei Korotkov, enabling different nodes to communicate with each other? A. The implementation of the gossip protocol for transactions and blocks. B. The finalization of the developer CLI and testnet packaging. C. The establishment of the peer-to-peer networking foundation. Or D. The definition of the fork choice mechanism to resolve competing chains. So the correct answer is letter C, the establishment of the peer-to-peer networking foundation. The peer-to-peer networking foundation is listed as the upcoming milestone for the testnet alpha. Senior developer Andrei Korotkov explicitly stated that this milestone, which will give different nodes the ability to communicate with each other, is his next milestone after completing the persistent chain state. His work has included developing the architecture and specification for the extra logical APIs, which encompasses essential components like peer-to-peer communication layers. He has also been active in integrating external libraries such as P2P to support the development of an Agoras node. Question 4. What is the overarching goal of the testnet alpha release milestone for Taunet? A. To provide an initial, fully featured graphical user interface for all users. B. To integrate external large language models for natural language processing. C. To bring TauNet online as a live, decentralized network where users can define its behavior by submitting rules on chain. Or D. To achieve full software synthesis capabilities for automated code generation. So the correct answer is letter C, to bring TauNet online as a live, decentralized network where users can define its behavior by submitting rules on chain. The testnet alpha release is explicitly described as the upcoming milestone whose purpose is to bring TauNet online as a live, decentralized network. At this stage, users will gain the ability to define network behavior by submitting rules on chain, and the protocol will evolve as these rules are processed and applied. This release is intended to be a minimal critical mass to initiate a collaborative development platform. The team is actively rushing to finish it as fast as possible as their current top priority. Looking ahead, the Testnet Alpha release is the next major objective, and it promises to fundamentally redefine decentralized networks. This upcoming milestone is not just about launching a blockchain, it's about bringing TauNet online as a live, decentralized network where users themselves can define its behavior by submitting rules on chain. This will be the first opportunity for the community to engage with a system that truly evolves in real time, adapting to formally defined rules by its users. Unlike existing blockchains, often governed by a centralized development team, TauNet is designed to be fully controlled by its users, allowing you to directly shape its evolution and decide its future. The network's ability to change its own rules from block to block means it can continuously adapt to new requirements and algorithms without disruptive forks, making it the end game of all blockchains. The alpha release will inaugurate a collaborative development platform where collective intelligence and formalized knowledge drive the network's advancement, accelerating progress beyond traditional means. Tao's foundation in logical AI that the software is correct by design and free from the probabilistic uncertainties of machine learning, offering a system where what you specify is precisely what happens. The initial testnet will be minimal, requiring early participants to engage directly with the Tau language. This direct interaction is key to understanding the system's power. We invite you to stay tuned for these monumental developments by following the progress, studying the materials, and preparing to engage with the testnet alpha. You become an active participant in sharing a truly decentralized future. This is your chance to contribute to a project that aims to scale human collaboration and redefine software development itself. Keep an eye on the official channels for the upcoming testnet alpha release and get ready to be part of this groundbreaking journey. Thanks for watching. See you again. Bye.